Hello everyone, welcome to the Science Center Community Virtual Experience. I am your host, Ben Mraz, and I'm a summer associate here at CSU Stanislaus, and today I'm going to be teaching you how to convert a chicken egg to a bouncy object only using a little bit of chemistry. So let's begin with the materials we're going to need for this experiment. So first off, we have vinegar. Any sort of vinegar brand will do, but you have to pay attention to the acidity level of the vinegar. That's usually marked off somewhere along the label. For example, it says right here, 4% acidity. The reason why that's important to note down is because a higher acidity level might mean that the reaction will take less time to complete, or you might see better results. Next up, we're going to need a clear container. It doesn't necessarily have to be a beaker like I have right here. Any sort of plastic or glass cup will suffice, so long as you can completely see the reaction take place. And lastly, we're going to need our chicken egg. So first step is we're going to carefully place the chicken egg into a container like that. We're going to take our vinegar, pour vinegar into our container. We're going to pour enough vinegar so that the egg is completely submerged within the solution. So when we lift that up, you can see that the egg is completely covered by the vinegar. Now we're going to set that aside for 24 hours and let the reaction take place. Now after a 24-hour period, you might notice a couple changes happen to your egg. Number one, it might take on a translucent appearance, meaning that light will be able to shine through it. Alternatively, you might notice that it has a leathery texture on the outside of the egg. As soon as you notice these things, you know that the reaction is complete or that the eggshell is completely dissolved. Now, as we wait for that, let's delve deep into the chemistry of what's happening here. The active ingredient found within vinegar is something called acetic acid. Acetic acid has a chemical formula of CH3COOH and is something known as a weak acid, meaning in the presence of water, not all the molecules of acetic acid will dissociate. Next up on the list of chemicals we need to talk about is something called calcium carbonate, with the chemical formula of CaCO3. An important biological material, calcium carbonate can be found in many egg and seashells throughout the animal kingdom. While calcium carbonate is a salt, when dissolved in water, the calcium ion acts as a strong base. Within the solution, the acetic acid from the vinegar will react with calcium carbonate from the eggshell to produce calcium acetate, carbon dioxide, and water. This type of reaction is called a neutralization reaction. That's when an acid and base come together and will neutralize one another. Neutralization reactions often produce a salt and water. Be sure you join us for part 2.
24 hours later.
Welcome back, everyone. So in part 1, we explored a little about the chemistry of what's happening inside the speaker. Now we're going to have the opportunity to discuss the physics of a bouncy egg. We're going to explore a concept known as potential energy. The definition of potential energy is the energy granted to an object by virtue of its position. The best way to explain this is through a demonstration.
Picture an apple hanging from a tree. The gravitational pull from the earth compels the apple to fall to the ground. However, the strength of the stem prevents it from falling. This generates gravitational potential energy. Eventually, the force of gravity will overcome the strength of the stem. At that exact moment, potential energy will instantaneously get converted into kinetic energy by the force of motion, propelling the apple to fall towards the ground. A couple things matter when considering an object's potential energy: the object's mass, height, and acceleration due to gravity. All of these values come together to mathematically define potential energy as PE equals mgHg.
Now in this part of the demonstration, we're going to be measuring the potential energy of our egg. Now a couple things that we need is the egg from part 1, something to catch the egg as it falls. So in my case, I have this plastic little sheet, but it could be a large plate or anything like that. A ruler to measure the height. It doesn't have to be this big, any sort of ruler would do, as so long as it measures centimeters. And a scale. A scale is not really that necessary, as an additional number will be provided to you, but if you have a scale, it does come in very handy. So our first step is to take our egg, place it on the scale, or measure the mass. If you don't have a scale, a number will be provided to you in our worksheets. So this egg weighs 51.19 grams. So that will be our mass for this demonstration. Now we have to measure the height of the egg. So let's position the egg over this plastic. Make sure our ruler is flat on the ground. And we're going to measure the height from the bottom of the egg. So we're going to drop it at a position of 60. Is everyone ready for this? And our egg smashes on the ground. So now the height from the egg drop was 60 centimeters. Let me grab my calculator. So the height of our position before the drop was 60 centimeters. Now the interesting thing about the acceleration due to gravity, or the force of gravity acting upon the object, is that it's the same everywhere throughout Earth. There's tiny little variations, but acceleration due to gravity is always measured at 9.8 meters per second. However, we have all our values, but we're not quite done. After we found our values, we have to now convert these values so they can appropriately fit the potential energy formula. So we could do this in a simple way. Mass in the potential energy formula is actually required in the units of kilograms. Here we have grams. So in order to convert grams to kilograms, all we have to do is take our number and divide it by 1,000. And that will be 0.05119 kilograms. Next up is we have to take our height and divide it by meters. So it's a very similar process. In order to convert centimeters to meters, we take this value and divide it by 100. So that'll give us 0.6 meters. And the acceleration due to gravity could actually stay like that. So now we plug all this into our potential energy formula. So we have 0.05119 times 0.6 times 9.8. Let me do a quick calculation here with my calculator. 0.6 times 9.8. And this will yield us approximately 0.3 joules. So that is the potential energy of the egg during the maximum height. Thank you for joining us, and be sure to check out the worksheets that we have for you for more detailed instructions on how to follow along and a couple practice problems.